I'm Grayson Barnhart, and in this demo for assignment 3, I'll walk you through the experimental results for the AI algorithms applied to tic-tac-toe and Connect 4. I've implemented Minimax with and without alpha-beta pruning and a tabular learning agent. I'll explain the 12 graphs in order and then show you an interactive game demo. So for graph 1, there's a bar chart of the average node expansions in tic-tac-toe when using Minimax versus alpha-beta pruning. On the x-axis, you see minimax and alpha-beta, and on the y-axis, the average number of nodes evaluated. Notice that the alpha-beta bar is much lower, and this illustrates how pruning effectively cuts off the unnecessary branches and reduces computational effort. So for graph 2, it's a plot of the win history for the Q-learning agent during training. Each point represents whether the agent won, which is 1, and didn't win, 0 in each episode. You can see that as the episodes progress, win frequencies increase, and it indicates the agent's performance is improving over time. For 3, you can see the cumulative average reward across the training episodes. The x-axis is the episode number, and the y-axis is the running average reward. The upward trend in this graph confirms that this agent is learning, and its average reward increases, which demonstrates a successful learning curve. Then you can see in graph 4, we examine a moving average of game lengths computed over a 100 episode window. The x-axis represents the training episodes, which are windowed, and the y-axis is the average number of moves per game. Changes here hint at strategic improvements such as quicker wins or more efficient play as the training continues. Graph 5 is a bar chart, and it shows performance outcomes when the Q-learning agent plays against the default opponent in tic-tac-toe over 200 games. The bar represent wins, draws, and losses. A higher win count indicates the agent is effectively learned to outperform the rule-based opponent. Then we move on to Connect 4. So this one has a similar performance metric over 100 games. Despite Connect 4's increased complexity, you can see a win, draw, loss distribution for the Q-learning agent. This confirms that the learning algorithm adapts well even in a larger state space. So then we have 2 strategies directly, Minimax or its alpha-beta version versus the Q-learning agent in tic-tac-toe. The bar chart shows wins, draws, losses from the 200 head-to-head games, and this direct comparison shows the strengths and trade-offs between the heuristic-based and learning-based approaches. Then we have Connect 4 head-to-head. This uses the depth-limited alpha-beta search against the Q-learning agent over 100 games. The outcome here shows insights into which method performs better under competitive controlled conditions in a more complex game. Then we have a line plot analyzing the effect of different learning rates alpha on final cumulative reward. The x-axis shows various alpha values, while the y represents the final performance. Peaks in this graph allow us to identify the optimal learning rate that maximizes the agent's performance. And then we have graph 10, which illustrates the impact of varying discount factors, or gamma, on performance. As you can see, the final cumulative reward changes with different gamma values, and this shows the importance of the agent places on future rewards, showing us an optimal gamma for balance between immediate and future gains. Then we have the effect of exploration rate. So we examine how the exploration rate epsilon affects learning. Again, a line plot is comparing the different epsilon values with the final cumulative reward. This graph can show us the best trade-off between exploring new strategies and exploiting known ones, ensuring robust learning. So now if I scroll down a little bit, you will see that I have the tic-tac-toe 95% confidence intervals. So this revisits our node expansion for the tic-tac-toe, now with the confidence intervals displayed as error bars. So this presentation confirms that even with the statistical variability, the advantage of alpha-beta pruning over plain Minimax is very consistent and reliable.